In order to learn any programming language, the best way is to start writing the programs, right? So I suggest that you start writing the programs right from the first day. So here also I'll start with a program and explain you how to learn the programming language, especially C programming language. Now for this programming language, I suggest that you follow the Linux programming environment. The reason is, if you get into any product-based company, generally all the product-based companies will use Linux operating systems in order to have their products built on. Now even if in your college if they are using Windows, I suggest that in your laptop or in your desktop you install one Linux operating system and you start working on it. Okay, so all the programs here, I assume that you are working on a Linux operating system. And next thing is, if you want to follow a good book for this, especially for this one, I suggest that you follow the C programming language by Dennis Ritchie. Even I too follow the same book, but then the problem is it is a complex book. If you directly start reading it, if you are let's say BTech first year, or if you are not very comfortable with C language, if you start reading it, you might not be able to understand. So follow my videos, and after you finish the videos, if you read the book, it will be very, very beneficial. Okay, now I assume that you are new to Linux and C, and so I'll start explaining you both of them simultaneously. In the sense, wherever I need Linux commands, I'll just give you the Linux commands as well. So first thing is, you need to create the program, you need to edit it, and you need to save it in a file. So the best editor in Linux is Vim or VI editor. So go to the command prompt in Linux and you just give this command VI followed by the file name, the name with which you want to save the file. Let us say the file you want to save is, let us say file itself, FILE, file.c, right? Generally, if you are writing any C program, it is a convention that you use .c as the extension. If you are writing C++, you generally use CPP. If you are writing Java, you generally use .java. That is just a convention. Okay. Now, once you type this, you are going to get a window, right? So that is the editor. Now in this window, you just type this entire text: hash include studio.h, void main, printf hello. And after this is done, you give colon wq. If you give it and if you type enter, then the file will be saved. And now again you go to the command prompt, and once you have saved this file, just try to compile it. Now we are going to use the GCC compiler, which will automatically be installed in your when you install this Linux in your computer. It is also going to be installed. You need not install it in many cases. Now what is GCC is, it is GNU compiler collection, and this is the software which you are going to invoke in order to compile the file. So when you write GCC, this is the command, this is the command which is going to run that software. Now what is the file that you want to compile? File.c, you just give it. So GCC file.c is going to compile this file, and it is going to produce an output a.out, which will generally be saved in the same directory in which you are working in. Now if you want to run it, then you just give ./a.out. This is the command which you are going to run this file. Okay. Now if you run this file, you are going to see hello world. So there it is. You have written your first C program, right? A simple program which has displayed hello world. Now even though it is looking so simple, actually what happens when you write this, and what is compiler, and what is this high level language? So there are many things that you might have to see. We shall see all of them one by one now. Okay. Now if you see various lines in this program, the first line is containing hash include studio.h. Now studio.h means it is a header file. it is a file. .h means it is a header file, right? So what is a header file? Exactly what it is we shall see later. But then stdio stands for standard input output. Now if you want to give any functions, if you want to use any functions which are responsible for reading the input from the keyboard or writing something onto the screen, generally we have to include this std.h, right? And since you are using printf here, you are supposed to include it. Okay, now if you look at this hash, generally hash include is called as preprocessor directive. Hash include and hash define are called as preprocessor directives. Now by writing this line, what we generally do, what is the main intention of this line is, it is to tell the preprocessor to include this entire file, which means just you delete this line and you include whatever are the contents present in this file into this file, which means our file name is file.c, but then there is a file called as studio.h, stdio.h. Now you go and fetch that file stdio.h, and whatever contents are there, you just paste all the contents here before you process it further. That is the meaning of it. Similarly, there is one more directive, preprocessor directive, called as hash define, right? Now hash define is also a preprocessor directive which is used for macro expansion. Now exactly what is this macros and what we do, we shall see later, but then just remember that whenever you see these two lines are intended for the preprocessor. Now what is a preprocessor, we shall see shortly, don't worry, I'll go step by step. Okay, and now the next one is void main. Now if you observe it, this is a function. Now whenever you see any name followed by these two brackets, that is called as a function name, right? And after that you are going to have the function body, right? So the function body is going to start with curly braces and end with a curly brace. Now what will this function body contain? Some commands, right? So now if you typically look at a C program, it is generally going to contain these two parts. One is it is going to contain functions which are going to do some task, and how are they going to achieve those tasks is by having commands inside the body, right? For example, you can think of this printf as a command, or if some other line as a command, right? And then it is going to have variables, right? A C program can simply be understood in terms of these two. It is going to contain functions and it is going to contain variables. Variables are used to store the data and functions are used to do some tasks by using the data. Got it? So here in this case, if you see this main, this main especially is this main is a special name. In general, in a C program, you can use any name for a function, but then only one exception is there. If you have to run a program, you are supposed to include this main function in that. Whenever you start running a program, your your program will start running from the main function. So when you give the command, let's say /a.out, right? Then in order to run this program, our operating system will search for the main function inside the program, and then it will go into the main function and will start executing from there. That is why every program, if you want to run it, should contain main. Apart from this, if you have any other functions, you are free to use any name, right? And then after a function, you are going to see these brackets, right? So inside these brackets, you are going to pass some variables if you want to pass it. Now for example, inside this function there is one more function. See this, printf followed by some arguments. This is called as a argument. Argument means we are trying to send something to the function, right? So after printf, again you are going to see the brackets. Within the brackets you are going to have some arguments. In this case, this is just a string. Whenever you see a string within these double quotes, that is generally called as a string constant. Okay, now what we are trying to do is we are trying to use this printf function and we are trying to send this data to the printf function so that this function will use this data and do the task. But then where is this function present? It is present in the library, right? So later we will link this file to that particular function, and then we execute it. Okay, I'll show you what happens exactly in some time. So now understand that this is a function name and this is a function name, right? And now you have ended this line. So every line in a C program is supposed to end with a semicolon, right? So next one is your entire function is going to end here. Okay, so this is a simple function. Now let's see, if you observe it clearly, this entire thing is written in English, isn't it? But the problem is, since our computer doesn't know English, you have to convert this high level language into binary code, isn't it? So for that reason we are going to use the compiler collection, right? Now this compiler collection is going to contain various modules which will take this high level language and it will go on converting this high level language into a low level language step by step. Now what are all the steps involved in this compilation? We shall see it now. Okay, so what did you understand here? It is a high level language and now it has to be somehow converted into bits and bits so that our computer can understand, but then we are not writing the program in bits because we are not comfortable writing it that way, right? And we are comfortable in understanding English language, that is why I am writing it in English, but then our computer doesn't understand it, so I am going to use the compiler, right? Now let's get into what happens when we try to compile it, right? What are the various phases we have and all. Okay, in general, not just about C programming language, any programming language which has to be compiled will generally follow all these phases, right? So you are going to give a high level language initially. When you write the program, you are going to write in a high level language like English. Now initially that will be taken by preprocessor. Now what is the main purpose of preprocessor is, one thing is it will remove all the comments. So what is comment is, just for the sake of readability, if you are writing a program and later if someone else has to read it and understand it, it is better that you include some comments in the file. So they are just helping the users to make the program more readable, but then they doesn't have any role to play in the execution. Therefore someone has to remove it before you give it to computer to execute it. So removing the comments will be done by preprocessor. Along with that, you are going to have your program will not be complete unless some other information has to be included in it, right? Therefore you have to sometimes include some other files. They are called as file inclusions, right? So in order to include the file, you can write some commands inside the program, and those commands will be taken by preprocessor, and the preprocessor will fetch that particular file and it will include in our given file, right? So an example of this is, we have just seen hash include. So whenever I write hash include some file name, it means that you take this file and you see whatever text is given in this and include in our file, right? And this file inclusion is done by our preprocessor. Now apart from it, there is also macro expansion. Now what is macro expansion is, I'll tell you later when, but then just remember that there is something you can use it as hash define. So there you are going to use macro expansion. Now all these three things will be done by preprocessor. Now once you give the high level language to your preprocessor is going to do all this, and it is going to produce again a file which will be still in high level language. That is just simply called as pure high level language. I mean, there is no other name, so we are using it as pure high level language. Okay, now after this, your compiler is going to take this pure high level language file and is going to compile it, and output of the compiler will be an assembly language file. Now if you look at this assembly language, it will not exactly be in a format which can be read by the machine, but it will not be as high as the high level language, right? Therefore once you convert the program into assembly language, then depending on the machine in which you are working on, every machine will have its own assembler. Now that assembler will understand this assembly language and convert it into machine language, right? You can think of this assembly language as some kind of intermediate representation if you want to understand it. An intermediate representation which will be easy for to convert it into machine language, but difficult for a user to directly write in it. Okay, so this high level language is very close to the user's language, and this assembly language will exactly stand between high level language and the machine language, right? And every hardware, the architecture, it will have its own assembler, and your compiler will know what is the hardware for which it is compiling, and depending on the hardware in which you are going to run, your compiler is going to generate that specific assembly language. Got it? Like x86, right? So I mean, let's not get into many details, because since it is introduction to C programming language, and I'm sure most of you doesn't know what I am talking about here in detail if you are in first year of your BTech. So let's try to be I'll just use some informal language to get you used to this. Later we shall see them in detail. Okay, and now once you give this to assembler is going to convert this assembly language into the machine code. But then this machine code is not directly runnable in most of the cases. The reason is you are going to have many files which are compiled differently, which are compiled individually. Later you might have to link all of them to run it. For example, in the previous case, if you observe it, you have written a you have in your file you have written a function, right? Main is the function there, and inside the main you have used printf, but then you have not actually given the code for printf. Now the printf is present somewhere else in the library, right, and that is written in a separate file. Now these two files have to be linked, right? Now that is where your linker is going to play a major role, right? So this linker and loader, they are going to convert this relocatable code so that it will be finally, your operating system will be finally able to run it, right? So what is this relocatable code? You can leave it to the later part. You might not be able to understand it as of now. So for now you can understand that there are various things which are going on in the compiler. When you just use the command GCC, there are all the things which are going on. Now the tricky question is, will I be able to see what is the output produced after every phase, right? Yes, you will be able to see it. Now here if you observe it, here I have directly given GCC file.c, and now I have shown you that this high level program file.c is somehow directly converted into a form in which it can directly execute, and you are executing it. But then intermediate, there are these many phases, and you can see what each phase is going to generate, right? Now if you want to see what each phase is going to do, you can use this sequence of commands. Now let us say your file is file.c. Now instead of directly giving GCC, you could give GCC -e followed by, let's say, this file.c. Now if you see this, use this command, you are going to get a text which is going to be printed on your screen. Now that text will show you how the file will look like, this file.c will look like after pre-processing phase, right? Therefore, if you want to see what happens after pre-processor phase, you just use this command GCC -c. Generally what happens is all the comments will be removed if you have any comments. Okay, I didn't tell you what a comment is. Generally you can write a comment like this. You can put two slashes, and then you can write this is a function, something like this. Now such lines will be deleted, right? So you can see that all the functions are deleted, and you can see that this hash include file is substituted or replaced with completely some other text which is from that file, and also you can see that hash define are also removed. So you can see all such things happening here. So if you give this command GCC -c file.c, you are going to see what happens to the file after pre-processing phase, right? Now let us say the file produced is saved as file.i. If you want to save this file, you can just use a pipe, or you can just put -o, or you can just write like this, the command. I'm just writing the command. So $GCC -c file.c, you can just write like this, file.i. Now why I? It is just a convention. Okay, generally we follow the convention that after pre-processing the file will be named as .i. Now this .i file, if you want to see what happens after compilation, now generally what happens after compilation, see this, after compilation your pure high level language is supposed to produce assembly language code. Now if you want to see the assembly language code, you just take this file.i and you give this command, which means if you give this $gcc -s, okay, one more thing, capital E, and here it is capital S, okay, minus capital S, right? Now if you give file.i, whatever you get here, or you can directly give file.c as well to this. Now either you give file.c or file.i, it will finally produce assembly code and it will store it in file.s. You can see that a new file is going to be created, which is file.s. If you want to see what are the contents in it, you can use the command vi file.s. Now if you see this, what are the commands present in this, you will see that it is all in the assembly language. Now that assembly language will be specific to the machine you are working on. Depending on the architecture, there will be different assembly languages for different architectures, right? So that will be hardware dependent. Okay, now you are going to see this assembly language here. Okay, now this assembly language file, if you have to assemble it, I mean if you give it to the assembler, then you are going to get machine language, isn't it? So if you want to see what happens after assembler, right, so you can take this file.s and you can give gcc -c. Let us say the command is $ followed by gcc -c. If we give file.s, this is the command which is going to be given, then it is going to produce file.o. Again, one more thing, here you can directly give file.c or you can start with file.s. Whatever you give here, finally you are going to see a machine code, right? Now if you try to open it and see it, it will all be in a zeros and ones. I mean it will not be in a readable format. Till here it will be in the readable format, but if you try to open it, it will not be in a readable format. Okay, which means it is now in machine language. Now if you have many files written separately, and if you have to execute them, and in case if you want to execute them, if all of them have to be linked together, then you can finally give it to the linker, right? So you can give many files. Let us say this is file.o. You have separately compiled some other file, file1.o, and you have separately compiled some other file, file2.o, something like this. Now you can link all these files together if they are related, right? You can link all these files together using this gcc -o command. Now this is the command which is used for linking, right? gcc -o, if you give file1, file, all these files, then it is going to produce the final output, right? Now the final output will be stored in a.out. Okay, so you can do it individually. See, all these phases, in order to compile the file, you can directly go with gcc. You need not do all these things all the time. Out of curiosity, if you want to see what is really happening, and if you want to learn and inquire in depth, then you can use all this and just check it. It doesn't mean that you have to do these commands every time. Okay, you can just go with gcc, but it is just better that you understand what is going on, okay, so that you will have an in-depth understanding. Now one more command is gcc -wall -save -temps file.c. If you give this command, then all these temporary files will be saved. So instead of giving finding these files one by one, if you want to save all these files at once, and if you want to see it later, you just give this one command. By giving this one command, file.i will be created, file.s will be created, file.o will be created, and now you can see all those files. Okay, so this is all about the high level view of what happens when you try to compile a file. Okay, now let's see other details one by one. As I told you, the main way, the approach that we follow is we take programs and then we try to analyze them and we teach you through programs. Okay, and also if you are trying to learn the C programming right from scratch, it is better you execute whatever program I give you. Okay,